Hello everyone, welcome back to my YouTube channel. In this video, we are going to learn how the switch is going to learn the MAC address of each end devices. So I'll be using my packet tracer for this, and this is the topology which I'll be using. It is fairly simple. I'm using a switch with not much configurations, which is default configs, and I have 4 PCs connected to it. And we are going to learn how the switch is going to forward frames the first time and the second time, and how it makes entries on each attempt of a device communicating to another device, and how it makes entries on the MAC address table for each devices when they communicate. So let's console into the switch first. So we need to see if there are any entries already there in the MAC address table, and we can do that by using the command show MAC address table, and we don't see any, and this is good, so we can start. And before that, we need to assign IP addresses to each of these end devices. Let's do that. I'm going to be using a class C IP address, and let me assign those IPs. And in this case, we will not be needing any gateway. Just need an IP on these devices, that's it, until they are not going out of the LAN segment to reach another network. So I'm just giving the IP address and the subnet mask. That would do. And default subnet mask /24 92.160.1.3. There you go. And for the last one, 92.168.1.4, and that is done. Now let's check if something has changed on the switching table. Well, it should not actually. Nothing should be changed. That means you should not be having any entries in the table. Well, it does make some entries already. So what we are going to do, I am going to flush this table. You can use the command clear MAC address table to do that. And let's check MAC address table again, and we don't see anything. Now what I am going to do, so we are going to learn the, as I am on switch and I want to learn the MAC address of these devices. Let's say PC0 wants to communicate to PC1, and I'm going to put these things in simulation mode so we can see what is going on in a step-by-step process. Okay, let me send a message from PC0 to PC1, and let's see what happens. So there you go, that's where the message is going. Okay, the message has hit the switch now. Let's see the MAC address table now. If you see there, we have not created any VLANs, and so that is default by VLAN 1, and this is the MAC address of the PC which just sent the frame to the switch. This is the PC0 MAC address, and it is connected locally on the switch to fast ethernet 0/1, and the switch successfully made an entry on its MAC address table for PC0. And let's see what switch does now once it has made entry. Now you see the switch has sent that frame across all the connected links, because that was the packet going out asking for an IP address of the other device, which is PC1, and that was only to be received by PC1, and PC2 and PC3 are discarding the message. By default, switch initially does broadcasting once when it receives a frame, because it does not know where the destination is, and once it receives a response back from the intended receiver, it is going to make another entry in the switching table or the MAC address table. Let's see what happens next. Let's see what happens when the response was response comes back from PC1 towards the switch. Let's see the changes in the switching table, and we see the response back from PC1 hitting the switch. And let's check the CLI again of the switch, and let's check the MAC address table. Is there any changes? Now we see this PC1 is connected on fast Ethernet 0/2, and there is an entry on the switch MAC table for fast Ethernet 0/2. So once the frame has received on the switch, so that is where the source interface frame, the frame has come from the source device. What switch does is, once it receives a frame, it is going to map the MAC address of the source, or you can also, on the other side, you can also say it as the sending device. It is going to map that particular MAC address onto the receiving port, and it made an entry now. Now what happens? The switch is already know switches already know where the PC0 is resided on its switch port. Now it is not going to do any broadcast, it is simply going to send the message back to PC0. This is unicast. Let's check if there is any changes in the switching table. Should not be, because the switch has learned only 2 MAC addresses as of now. This keeps happening over and over again until it learns all the MAC address of the devices which it is connected. Let's say now PC1 and PC2 entries are there on the MAC address table. Let's say PC2 and PC3 wants to communicate, and let's see how that goes. I'm going to delete the existing packets, and I'm going to send some packet from PC2 to PC3, and we are going to see the entries at the end of the packet, at the end where the packet is received on PC2 again. That's the response, and let's go. Now the packet hit the switch. It does not know where the destination is, so it is going to broadcast that frame out of every other port except where PC2 is connected. Let's see that. See, there goes out 3 messages, and PC0 and PC1 is discarding that, PC3 is accepting that, and it is going to send a frame back in response back to the switch as a response to PC2. When this is happening, there is already an entry in the switch for PC2. Let's see that. Let's see, there is another MAC address table entry on the switching table, and we see that on fast Ethernet 0/3. Is that fast Ethernet 0/3? Yes, that is. Let's see what happens next on the response. So PC3 is responding back, and switch receives it, and there should be another entry here on the switch. There we go. We have learned 4 MAC addresses on the switching table. Once every device starts communicating and the response comes back, the switch has made entries in the switching table, and this is how the switch learned the MAC address of the devices dynamically on the switching table. This has been learned dynamically. So there was a broadcast initially, but now this is a unicast because switch already knows where the device is connected. It is not going to do broadcast, and this is what enhances the, or we also call the switch is an intelligent device. This is the reason we call it as an intelligent device, because okay, I'm going to delete this scenario. Let's see the packet going from PC0 to directly PC3 and what switch does. From PC0 to PC3, and what switch is going to do. Let's see. It hits the switch, and the packet again broadcasted and it is not received by PC1 and PC2 because it was for PC3. And the response back, and it goes back to PC0. So this is how the switch learns the MAC address of each devices on its interface dynamically and map it to the local interfaces. That's it for this video. Thank you for watching. See you next time.